A new study claims Earth has seen an increase in asteroid impacts over the past 290 million years. The findings, reported in the journal Science, are based on new dating techniques being used to determine the age of impact craters on the Moon. Scientists using images and thermal data collected by NASA's Lunar Reconnaissance Orbiter spacecraft have calculated the age of large lunar impact craters across the Moon less than 1 billion years old. By comparing the impact history of the Moon with the Earth's craters over this interval, the authors discovered that the rate of sizable asteroid collisions has increased by a factor of 2 to 3 on both bodies over the past 290 million years. For decades, scientists have tried to understand the rate at which asteroids hit the Earth by carefully studying asteroid impact craters on the Moon and by using radiometric dating of rocks around them. The problem is, Earth has far fewer older craters than expected compared to other bodies in the solar system, making it difficult to find an accurate impact rate and determine whether it's changed over time. Scientists always assumed that the earliest impact craters on Earth have been eroded away by wind, water, and geological processes, mechanisms not present on the Moon. But one of this study's authors, William Bottke from the Southwest Research Institute in San Antonio, Texas, says his research indicates the Earth has fewer older craters on stable terrains not because of erosion, but because the impact rates were actually lower prior to about 290 million years ago. Though large impact craters are rare, the Earth and the Moon are hit at roughly the same proportions over time. Lunar craters experience little erosion over billions of years. But scientists couldn't pinpoint their ages until NASA's Lunar Reconnaissance Orbiter started circling the Moon a decade ago, studying its surface. The spacecraft's thermal radiometer, called Diviner, measures the heat radiating off the Moon's surface. By looking at these data during the lunar night, scientists were able to measure how much of the surface is covered by large warm rocks, as opposed to cooler, fine-grained lunar soils. Large impact craters formed in the last billion years or so are littered with boulders and rocks, while older craters are far smoother. Using a relatively new technique designed to calculate how long it takes to reduce lunar rocks to soil, the authors were able to calculate the age of lunar craters younger than about 1 billion years. They found that the rate of large crater formation on the Moon was about 2 to 3 times higher over the last 290 million years compared to the previous 700 million years. The reason for this increase in impact rate is unknown. It could be related to large collisions taking place more than 300 million years ago in the main asteroid belt between the orbits of Mars and Jupiter. Such events can create debris streams that ultimately reach the inner planets and the Earth-Moon system. The authors were also surprised when they compared the ages of large craters on the Moon to those on Earth. Their similar size and age distributions challenged the theory that Earth had lost many of its craters through erosion on stable terrains back to about 650 million years ago. The authors were able to confirm their deduction by studying kimberlite pipes, long extinct volcanoes stretching in a carrot shape several kilometers below the surface. Scientists know a lot about the ages and rates of erosion of kimberlite pipes because they're widely mined for diamonds. They're also located on some of the least eroded regions on Earth, the same places where we find preserved impact craters. Scientists found that kimberlite pipes, which formed about 650 million years ago on stable terrains, had not experienced much erosion, indicating that large impact craters younger than this in the same regions should also be intact. The findings also have implications for the history of life on Earth, which is punctuated by extinction events, followed by the rapid evolution of new species.